I would divide VLSI into three main categories based on three main skill sets required for job opportunities. So they are analog VLSI, digital VLSI, and your EDA tool design. So let's look at each of them in a little more detail. For analog VLSI design, you will need a completely different skill set of designing smaller components from transistor devices and putting them together, characterizing them, tuning parameters, and etc. etc. So some of the examples of analog VLSI design are these. Amplifiers. Now these are some of the things that we cannot do any other way. We have to have analog VLSI design for these things. So amplifiers, op-amps, all kinds of amplifiers, including other categories like BJT. We need analog VLSI design. Buffers. Now when you have long interconnects, you need buffers, you need current boosters, you need comparators, oscillators, PLLs, current sources, voltage regulators, sensing circuits, filters, memory cells, latches. For that matter, any digital block is internally analog. You take flip-flops or any gate inside it is an analog characterized block. ADCs, DACs, these are just some small examples. So analog VLSI design requires a different set of skill and generally requires good understanding of modeling and characterizing and good behavior analysis of transistors and circuits. So if you have a decent experience in designing these things, understanding and explaining why such a behavior is seen in circuits, and if you can model them in equations and change parameters and add parameters to explain the behavior of a certain device, then you could go for analog VLSI design. And the job opportunities are slightly limited compared to the other two areas because it needs good skill and it needs a certain experience. But you are welcome to apply, and they do take freshers in analog VLSI design. And companies often do mixed design also, mixed signal design, where you have some blocks of digital and some blocks of analog. And so that also needs a good understanding of analog VLSI design. In any circuit, in any chip, we have some portion of analog VLSI design. We cannot ignore analog VLSI design. Of course, most of the things are done in digital, in big processors and SOCs, DSPs. These days, most of the good work is done by digital, but you have to have some analog components inside, some analog blocks, at least ADCs, DACs, buffers, and things like that. In this course, we are going to focus on digital VLSI design. As I said, most of the work is done by digital design these days in a chip, in an SoC, for example. Most of the components will be digital. Because of these advantages, it has reduced sensitivity to noise. So the noise margin is really high. The distance between a valid 1 and a valid 0 is really high. So you don't expect a 0 to suddenly fall and become 1, or a 1 become a 0. This is not the case in analog VLSI design. In analog, a small change in a value, a small change in threshold, for example, could alter your circuit in a big way. But that's not the case in digital VLSI design. So you have two good levels, and there's a considerable distance between a 1 and a 0. So you have reduced sensitivity to noise. A small noise cannot switch your value from 1 to 0 or 0 to 1. Right, so you have increased flexibility and security. You can design a circuit today and customize them tomorrow for a different application or for a different bus width. Say for example, you designed a 4-bit multiplier today, and tomorrow you can easily upgrade that into an 8-bit multiplier or a 16-bit multiplier, etc. You designed a 8-bit ALU today, you can upgrade that to a 32-bit ALU pretty easily. And you can add a lot of security components, security features, encryption, put a lot of features inside your digital design. And you can automate the entire design and test flow. Most of the digital design flow is automated. You have ready-made scripts, and you just have to monitor the log file. And even though you have multiple tools, you have a direct flow from one tool to the other tool to continue your automated design flow. And digital eliminates ambiguity. So since the noise margin is very high and you have a clear output, you have a sure output. We say in digital, if it works in simulation, it will work in real life also. Now that is not the case for analog design. So analog design might work very good in simulation, but when we fabricate things, we see a lot of ambiguity because of the small changes, because of noise or cumulative changes through the circuit, it affects. So those cases do not apply for digital design. So if it works in simulation, we can guarantee that it will work in real life also. And as explained earlier, digital design works only in saturation, and it does not work in the active regions. So because of this, your static current is approximately 0. And the biggest advantage is that we only worry about logic. We are not much bothered about parameters inside. Of course, yes, there is a certain worry, but the main worry is only about logic, and we can comfortably give importance to designing the functionality of the chip, and the rest of the things we can assume to be taken care because the cells are already made for us by the analog people. When we see ASIC design flow, we will see a lot of different steps that are followed in digital VLSI design, and every step has a unique job opportunity. You can choose to become an expert in one of those 14 steps, and you could easily get a job. And it is very easy to get a job on digital VLSI design. And one of those steps is what is focused on this course, that is RTL design using Verilog HDL. Right. So the third job opportunity is in the EDA tool design. So this is a big industry where you would require skills like software skills, programming skills, and a good understanding of VLSI intricacies. If you understand VLSI well and you are very good in programming, you could go for EDA tool design. Now again, these companies are earning huge amount, and there are 3-4 big players like Synopsys, Mentor Graphics, Cadence. So these companies do very well, and there are lots of jobs that freshers can apply for. You would be working on interfaces, graphics, adding features, Mainly, you would work on implementation of complex algorithms. When you do circuit simulation, in the background there are equations that are modeled, and equations have to be computed. The important thing to remember in a tool design company is not to finish execution, but to finish it fast. How fast can you compute a particular output? Or can we do batch processing, parallel processing? How do we come up with faster results or different levels of results? Do we give all the output at once, or do we give the important ones first, then expand to other finer details? So things like that. So this is another area of job that is available for freshers. So put together, these are the three major categories that I see, and you can choose to apply for one of those. We will spend a lot of time on digital VLSI design, especially the RTL side.